So we're going to make a table of the joint relative frequencies. This is the back page of 7.4. So what we have here is a reporter asked 150 voters if they plan to vote in favor of a new library in the new arena, and the table is going to show the results. So this is a two-way table. If you guys decide that you do want a straight edge, I'll put them up there to start with. So we have to have enough room to do the yeses, the nos, and then the total. Okay, so on the top, just like here, the top is the library. This is going to be for the library. All right, so once you do the columns, I want you to go ahead and find the values. So here's the yes, here's the no, here's the total. Okay, see if you can keep going. Once you guys are done, read through, you can run through B and C. B and C are actually going to be very... It's not. It's mine. That's not straight. That's not straight. Yeah. That looks pretty good. I'm going to put yours up here and then I'll judge you.
Bro,
we're not trying to make ours straight, though.
mine looks like...
Ooh, those look very unequal.
Okay. Fashion police over here. Alright, so I want you guys to fill in the chart. So you're going to use the same technique. Okay, remember your total is given to you in the direction. So if it's 150 voters, how do you find this box? Oops. So if this is yes and no, I have to make this yes and no, or else it'll be confusing.
Oh, that would be...
Yes. Whatever they have here is what I'm going to use. Alright, so the yes and the yes is 21. So how do I find this relative frequency? Yeah, 21 divided by 150. Okay, so then for the next one, I have 57. So I can just do 57 divided by 150. And then the last one is the total. How do you find the total? After this. Yeah, you add them together. Yeah? Yes. 25, 2.
So it's a 52.
Yes.
So, library 1.
Well, remember, you're judging two different things, okay? So for the no's, you have the 30, but this is no to the library, yes to the arena. Guys, stop it. Why don't we worry about ourselves?
I'm erasing because I wrote wrong homework, so I'm done with it.
Okay, so if you have 0.48, okay, and then the total this way, you're going to add straight across. Okay, and then we're going to add here. Oh, sorry. This is 0.34. This one should be 0.66. Now, if you added correctly, then when you total these and you total these, I already heard it, what should this corner be? 1, because that represents the whole. Alright, now, the probability questions are very similar to what we did the other day. So it says, if you are given that a voter plans to vote no to the new library, what is the probability that the voter also plans to say no to the arena? So in this, you already have a given. So it's given that a voter plans to vote no. Do you guys remember from yesterday where that would go, the voting no? Where? No?
What?
You're not going to multiply it. So the given, remember yesterday we did the table with the regions, the Midwest, whether they were an immigrant, an emigrant, and a couple of them you had a given, and where did the given go? In the denominator, so in the bottom. So if you're given that they plan to vote no, this is going to be the total number that vote no. Okay. This is like the tables that we did. And then on the top, you are going to find the ones that they say no to the new arena, but they also have to vote no to the library. Okay, so no to the library. And the arena. Okay, so what's the probability that a voter plans to say no to the new arena and no to the library? We can use this table. So no and no would be 0.28. Okay, so we find the box with that number in it. And then the total that vote no to the library. Okay, we're just going to look at the library, which is here. The no's are 0.48. That is going to be your total. Okay, now, like I said, if it doesn't say like to write it as a decimal or a fraction, I do want you to write it as both. A really quick way to turn this into a fraction is to just move the decimals 2 places. So if you move the decimals 2 places, you have 28 over 48. What number goes into both 28 and 48? Yep, so divide by 4, and you will get 7 over 12. And then we're also going to write it as a decimal. So 7 divided by 12. And that is approximately 0.58 when you round. Okay, so again, when you're reading the question, let's try to highlight our given. So this one says, you are given that a voter plans to vote yes to the new arena. What is the probability that they plan to say no to the new library? Okay, so the given is in the denominator. Okay, so this is the total that vote yes to the arena. When you're thinking of the numerator, keep in mind there has to be 2 conditions. So they say no to the new library, but at the same time, they're voting yes to the new arena. So we have to look and see where it's yes to the arena and no to the library, which is going to be right here. So we're 0.2, right? So it says no to the library, yes to the arena. So yes and then no will be the 0.2. So this is yes to arena and no to library. Okay, and then the total that vote yes to the arena, now we have to look at the row. So if we look at the row, the total amount of yeses is going to be 0.34. So again, we're going to write this as a fraction and a decimal. So the fraction is going to be 2 moved over. So when you write the first one, it's going to be 20 over 34. And then we can cut those both in half. Okay, so 10 out of 17. And then again, we're just going to round it to the nearest 100. Okay? So this is 0.5, and then does the 8 round up or stay 8? Rounds up. Alright. Alright, then the last example on this one is about a company, and the company sells items in the actual store, online, and through a catalog. Yeah, I know. the last time you guys ordered through a catalog? Been a while? Okay, so, the manager looked at the sales, and there were 50 made that day, and looked to see which ones were paid for with a gift card. We're going to use conditional probability, so that's what we've been using here, to determine which method a customer is most likely to pay with a gift card. So we're going to be analyzing the gift card method. So the first one is we're going to find the probability that they are likely to use a gift card in store. So we have these lovely tallies here. Let's go ahead and write them as numbers. Yep, 6. Online would be 9. Catalog would be 4. The other method in store is 9.
Wouldn't it be 5?
Oh, my bad. Yeah. Thanks. 5 has a slash through it. Thank you. 9, and then this one will be 13. Last one. All right. Now, when you do the conditional probability and you're setting up your fraction, this is the probability that they use a gift card in store. So in the bottom, you want the total of in-store purchases. And then the top is going to be the gift card in store. Okay, so we are going to total how many total were in store. 15. So we just add straight across. So to find the probability that they used a gift card in store, it's the total of in-store transactions over the gift card in store. So 6 over 15. Can you reduce that fraction? Yes. So 2/5, and then do you guys know what that is as a decimal? Yep. It's like 0.2 times 2, so yeah. All right, so that is for your gift card in store. So for the gift card, or sorry, online, for the gift card online, we have the total online, and then we have the gift card online. So how many gift cards were used online? About how many gift cards? 9. Yeah, and then there were 22 total online transactions. Okay, can we reduce that one? Nope. Okay, so then we're just going to leave it as 9 over 22. And then let's round that to the nearest hundredth if we need to. Okay, so that would round to what? Yep, 24.1. Good. And you think you guys can do the catalog? All right, and then with your catalog, how many used a gift card? 5. How many total? 13. So when we add those together. Okay, so you have 5 over 13. Yep, and then, sorry, just reminded. All right, so which method, what's that?
6 makes 4, 5, and the 5.
No, you get. I call that the domino effect. So when you're rounding, you have to look at whatever place you're rounding to, the number directly behind it. So directly behind the second place there is the 4, so it'll be the same. If you were doing to the thousandth place, then yeah, the 6 would round that up. And then remember, the question is, when are you most likely to pay with a gift card? Yeah, so in this case it would be online, so we're going to write a reason. This is kind of a little preview of what AP Stats is, using these statistics to make a decision. So a customer is most likely to use a gift card online. Because 41% did so, compared to 40% in store, and 38% with the catalog. Really, they are all pretty close.
Why do we need that big one?
Yeah, you're just doing a summation of your findings. So in statistics, there is a lot of like writing out and summarizing in words what you have. Yeah.
The percentages there.
Say it again.
The percentages there. The decimals.
Yeah, it's so it's not the it won't be the total. It's just the percentage of these sales. So each one is separate. Okay, so your homework, we're gonna look at that on your calendar, and it's posted in Google Classroom.